Hello everyone and welcome back to my channel. If you're new here, my name is Ioannis Anifantakis and today we're diving into an exciting upgrade for your Android projects. We will be exploring how to enhance Jetpack Compose navigation with type safety. So by the end of this video, you will learn how to transition from the old method, which I showed you on as a hack on a previous video about passing parcelables between screens, which has many flaws, to a new, more robust type-safe approach that was introduced at Google I/O 2024. So, what are we going to build today? Here we will be building a simple Compose application that displays a list of people. You will be able to click from one person and view the details to another screen. Initially, we will review the old way that I showed you using passing parcelables using the backstack, which is more of a hack as parcelables were not actively supported by the Compose navigation. Then we will upgrade our navigation library to the one introduced at Google I/O 2024 to utilize type safety, making the code cleaner and more reliable. This new approach allows type safety for primitive types out of the box. But with a little extra code, we will make it also support custom navigation types. So we will have custom NavTypes, as they're called, that will represent our parcelables. Finally, I'll introduce a helper library I created that contains those parts of the code that we will write to support the parcelables and complex string serialization. With this library, you will not have to actually write all this extra code in order to support parcelables and complex string serialization, saving you from writing all that stuff that we will see in the project. But we will first write everything, see how it is, and then we will clean it up and you will see parcelables being supported almost as if they were primitive. So almost out of the box with my little library. So this is going to be a detailed and long video, so please grab a cup of coffee and let's get started. For the starting code, we will start where we left off, and that is we have screen A and we have screen B, and we pass a parcelable instance of a person class from screen A to screen B using the navigation's backstack. And that is, of course, not the optimum way, but we will build to improve that and see the difference with the type-safe navigation. First, let's say that we are using two libraries that didn't come up with an empty project. This is the Coil Compose library, which we use it in order to display in Jetpack Compose images coming from the web, like this one. And we also use the Navigation Compose library, which we use in order to navigate from screen A to screen B and then pop off the screen B back to screen A. For that, we are using version 2.7.7, which is the latest stable version, which currently doesn't support the type-safe navigation. The type-safe navigation is in version 2.8, which is still in beta. Now, for that, on the build Gradle, again, we just add implementation to those packages in our dependencies. And we also add the Kotlin Parcelize plugin in order to be able to mark data classes as parcelables. Without it, we couldn't do it. Then we have the person data class, which is a data class, simple data class that we just mark as parcelable. Okay, it has ID, section, name, image, URL, and landing page. You see the section. We made this in order to display how we can build sticky headers for lazy columns. If you want to see how this is done, it's earlier in the playlist. Then from the main activity, we just called the navigation route all. Well, I have it navigation route all because side by side, we're also going to build the navigation route new, which will hold the new approach that we're going to build on. For the old approach, which is not the optimum, we have a NavHost that uses a navigation controller. We have two destination routes. We have the main screen and the detail screen. Okay, and our starting route is a main screen. For that, we have a view model that populates 200 instances of myself. Then we pass it to our composable main screen, and then when we click on a person using callbacks, we return the person here to the on item click. That person is utilized by going to the current backstack entry of our navigation controller, and on the save state handle of it, we pass the person with a key that we decide. In this case, we call person. So that way, now our current backstack entry has a parcelable person under the key person. Then we just navigate to the detail screen by calling this destination. And this destination takes us here, where we use the previous backstack entry, which is the one from main screen, okay, that called us. And from there, we utilize its save state handle, and we obtain whatever object is stored under the person key, okay? And then we cast it to a person. And like that, we have reconstructed here on our detail screen the person parcelable, which we then just pass to the detail screen. As you see, the section and the person with the ID, everything comes from the first screen to the second. Okay, and then when we press the go back, we have another callback that utilizes navigation's controller backstack, so that we remove from the backstack the detail screen and come back to the main screen. And that's about our starting code. So let's start improving on that. Let's begin with the dependencies that we need for our new functionalities. So for that, let's open first our versions catalog file. And here, as you can see, we are using the latest stable version of Compose navigation component, which currently is at version 2.7.7, that doesn't contain the new functionality we want to take advantage of. So let me just copy everything from here. And now let's see. So here, as you can see, we have stepped up our version from 2.7.7 to 2.8.0 beta 1, which includes this new way to declare destination routes to our navigation by just defining them as objects or data classes. Other than that, as you will see, we have also added the Kotlin Next Serialization JSON in our library section, and in our plugin section, we have also added the Kotlin Serialization. So let's sync and move to our build Gradle. Now for our build Gradle file, what we need to do, first, we need to add this serialization plugin. Okay, so that's here, and also down here at the implementations, we need to add the implementation for Kotlin Next Serialization. Let me just copy it, put it here. So that's it. Let's sync, and now we are ready to continue. So let's define our new NavHost that will work by defining our routes through data classes and objects. So let's go here and create a new file. We will call it navigation route new. Okay, it will initially be the same as the old approach, and you will see how we make the same thing with the new way. So we can compare them side by side. Let me rename this old. So our actually new nav host that we define here is initially the same as the old one, okay? But in order to be able to see the changes, we need to calling the new one from our activity. Otherwise, we won't see anything. So let's put this side by side. And as you can see here on the left, we have the old way, and on the right, we have the new way, which are initially the same. So let's do this modification on our NavHost, where we will be passing singletons and data classes instead of string roots here, okay? That will give us the benefit that we will be able to pass data inside this data class. So they define both roots and arguments. So let's start by creating a sealed interface, and let's call it navroot. And let's start by defining our main screen. So the main screen doesn't take any arguments, okay? So this can easily be a singleton. So let's call it object main screen. And anything that we pass to the NavHost must be serializable, okay? And that's all there is for the main screen. However, in the detail screen, we will be passing a person instance. Okay, so a person that we obtain by clicking at our list item. So that cannot be just a singleton, it will be a data class, and let's call it detail screen. And the detail screen will take what? A person. So let's put that here, val person of type person. And that would be enough if we didn't mark it as serializable. But if we mark it as serializable, oops, you will see that the person complains a little bit. So let's open, see what happens to the person. So here, the person is a parcelable, but it's not serializable. So we need to be both parcelable and serializable for that. And now, as you see, the error has gone away. Generally, if we were working just with primitives instead of parcelables, this kind of definition would be enough. But in order to work with parcelables, we will need to say that the type that we are creating is a custom nav type, which we will see in a while. For now, let's go and define our main screen here. So instead of passing a string alias, we will pass a generic, and this will be navroot.main screen. That's it. Here also our first destination would be navroot.main screen. And for the detail screen, we will also say that this is a generic of navroot.detail screen. All right, so far so good. But how we pass data, how we pass a person from main screen to detail screen, well, this happens at the navigate. Okay, before we were putting at the backstack the person, and then when we were going to the detail screen, we were looking at the previous entry at the backstack, which was a little bit of a hassle. So here, instead of doing that, we will pass it during our navigate step. And what we do, well, we will be utilizing our data class. So we will pass a detail screen instance, okay? And that instance will contain our person that we obtained here, that easily. Now, when it comes to retrieving that, well, we can have our arguments. So first, what we were doing from the previous backstack entry, we were using the save state handle. Okay, so let's do something similar here. So let's say that our arguments is actually it, which it, as you see, is a backstack entry dot to root. And here we pass what to root for our detail screen. So that will be navroot.detail screen. And that means we are retrieving the arguments for the detail screen. And that's what we are doing here. So here on the same line, we were retrieving the person. So instead of that, we can say that dot person as well. So let's make it exactly the same, the equivalent. So val person, it to root for person instead of what we have here. So let's kill this line as well. And the person here is not nullable, so we don't need this let statement. And that should be it. And actually, if we were dealing with primitive types and not parcelables, this would be enough. However, if we run this, you will see that we come to some exception. And the reason is we haven't defined a custom nav type, which is something else other than primitives. So let's look at it now. Now, before we run our application and we see it crash because we haven't actually declared how our navigation component should handle a custom type, such as the person parcelable, let me make a small change here at the view model. I will tell you later why I did it, but I don't want to pass anything now on the URL and the landing page. I don't want to pass um, URLs because they will cause another problem, which we will attend later. So let's now run our application and see what happens. So by running it, you will see that it will instantly crash. And okay, let's go to logcat and look at what happened. So here you will see that we are getting an exception that's of illegal argument exception that says that we cannot cast a person of type person. So we see it here, a person of type person, okay, to a nav type. Make sure to provide a custom nav type for this argument. So we need to provide a custom nav type for this thing here. And if we look at the Google developers website, they say how to provide custom nav types. And they have an example where they have a parcelable, just like ours, which is also marked as serializable, just like ours. And for that, they define a custom nav type like that. So let's take their code and adapt it to our scenario. So going here, they defined search parameters was called their data class. Ours is called person, so we are going to call it person type, and it returns a nav type of the type that we want. The nav type is from the navigation library, the new navigation library. Let's import what we can. And here, instead of returning search parameters, we will return person. Okay, now we'll also put person everywhere. All right, so what this does, it should create a nav type of type person. Okay, here, as you can see, for this string, it's required from version 2.4.0 and lower, but it makes no harm to keep it. Let's just, instead of the string person, provide the person dot class Java name, which is again actually a string person. Okay, so that's it. Now let's make a small correction here. And this should be it. However, we have a deprecation and we better deal with deprecations. So our deprecation here says that since version 34, we need to change the way we address this. So since version tiramisu. So we'll return if the build version, and let's import build, is less than 34, or actually less than, let's call build version code tiramisu, which is the same as less than 34, but it's a better way to put it. We will return this bundle, okay? Otherwise, let's put the same thing, but the updated version that also requires the class name, which is person, come on, person class Java. Okay, comma, person class Java. Okay, so that's it. Also, let's get rid of the strike through. And we are supposedly good to go, but If we run it like that, you will see that we will still have another error, and that error is described here. Okay, we will run into the same problem because actually in the documentation they forgot to mention that we should also pass this thing. All right, so we should also pass serializable as value, of course, for person. Okay, and I would say that now we are complete. Let me close this. There's no reason to have this. Now we have defined our person type. All we need to do is actually pass it inside our destination here so that the details screen knows how to handle that parcel level. So for that, what we have to do is write type map. So the type map for we will map it a new type. So that would be of map of and type of, and that would take a person. Okay, and let me just import the type of. All right, and we have an index here. So to person type. All good now, but there is one problem we need to fix before we proceed with serializing our URLs. Here, so far, we have this code just to define a single parcelable. And it's too many lines of code just to describe a single parcelable. What if we had more parcelables? We would have more times the same code, exactly the same code, where the only thing we would change would be the generic that we use. So, is there a way to generalize this? And thankfully, yes, there is a way. We will create a function where we will pass the generic type we want, and this will produce an object of a NavType of that generic and get it back to us. So let's start doing that. So we will have a function, okay? And as we said, this function will be about a type of our preference. So for type T. Now, this preference will always be a parcelable. Okay, so let's say types that implement a parcelable. Okay, and now let's give it a name. We can give it any name we want, but because we're going to pass NavTypes, well, it would be nice if we make it a NavType extension function, right? So let's do that. NavType and companion so that we go into the static context, and let's give the name. A nice name is mapper, maybe, because we map types to NavTypes. So that will return what? As here we return the nav type of a person, we will return a nav type of whatever t we passed here, okay? Whatever type. So what would be the body of that? We already have the body. So that would be it. So here we will return that. But instead of returning a nav type of person, we will return a nav type of whatever t we have. So let's just but here replace every person with T. Okay, I think these are all. Now we come to see that we have a problems here when we try to obtain the class of that generic type. So here comes a concept of type erasure. What is a type erasure? Actually, when we declare generics, what happens is that with generics, we know at compile time the type. That's why we have this generic, so we don't make mistakes as we write and as we compile the code. But what happens once the code is really compiled? So when we come to the runtime. So when the code is compiled, the code is downcasted to object for Java or any for Kotlin. That means that any generic we pass ends up being an object, and the actual good old school casting takes place. Okay, so here, since this will get downcasted into an actual um, object, we cannot know the class that we pass. Okay, so to fix that, we can mark our generic as reified, and it fixes all that. But then you will see that reified is only applicable inside inline functions. So let's mark our function as inline. So what does an inline function do? An inline function takes the body of the function and appends it to the caller side. So whoever calls this function doesn't actually call it, gets a copy of that function. So when we mark um, a generic as reified inside an inline function, we actually replace that generic to the actual class at our reference point. So there, from where we refer to that inline function, we get a copy of that function with the actual class name. And that's now how we can get class information about our um, parcelable that is our generic here. So up here where we call this, we used to call the person type. Now instead of that, we will be calling NavType.mapper. And for the mapper, we will pass as a generic what? The person. And just like that, with this piece of code now, we can call it for any parcelable that we create without having to rewrite the same piece of code again. So let's run the app and see what happens. Perfect, the app is running. We get through to the main screen, then we get to the second screen and go back. Everything fine. But we don't have our images because if you remember, we said that we are dealing with a serialization bug. And now it's time to fix our serialization for URLs and generally for any string that contains escape characters, special characters that cannot be serialized. Okay, so what if we put back into the game our URLs? What happens then? We will encounter a crash because the parcelable that we are passing now gets serialized. Okay, so even though the parcelable mechanism is fine, serializing it's not. Initially, we see everything fine here because we are not serializing something. We just show it directly on the first screen. But to go to the second screen, we put everything into the data class here, data class where we pass the person, okay? And we serialize the person and pass it to the detail screen, okay? And that's what happens here at the navigation. So if we now go to the second screen, we got a crash. And let's look at it. So what it says here, our crash is, let me get to the top, is on our navigation destination that matches the deep link request, blah, 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 cannot be found in the navigation graph of Compose. Why? As you see, we serialize, we turn it into a JSON, the parcelable we are passing. But here, as you see, everything is red. Here, you see we got an escape. Okay, we have escaping characters. It's those backslashes. So how can we deal with it? Let's call URL encode or encode URL. Sorry, no, it's URL encoder. Yes, encode and pass our string. Initially, this will say that it's deprecated because actually we also need to pass the character type. So let me just copy and paste it here. character set. Now it's not deprecated. So let's do the first URL and not the second so that we get a crash, but we see how it goes for the first one. Let's run again. Okay, now we don't see images here because we actually need to decode them. Okay, let's click and we crash. So what happens here? You will notice that, okay, we have the same message. However, for the image URL, you see that everything goes fine. We are treating the special characters as normal characters. We are encoding them, okay? It's just when we get to the landing page, which is the second URL, but we haven't encoded yet, it crashes. So let's fix that as well. And actually, you see that by using the URL encode, we cannot just encode URLs, but actually any string that could use characters that could cause a crash. So it's a good practice to apply this actually to every string. So how this works, let's put this code, comma here. And now we have to go to our detail screen and to our main screen. And what we need to do is actually use a decoder. So URL decoder, okay, decode the image URL. So that's what we need to do this time, okay? And of course, again, to fix this deprecation, we need to also tell it about the character set. And the same also in the detail screen where we use the image URL. So here we can also URL decoder, decode, and do comma that. And let's run again. And okay, here I see the images, and clicking I get to see everything fine. So we dealt with the encoding and decoding of URLs because as we saw, when we serialize, we turn it all into a JSON object and we don't allow escape characters. But what we have seen now is a very bad practice. We put encoding and decoding inside our composables, inside our actual view model. So is there a way to fix that? And again, yes, there is a way to fix that, and that's what we are about to see now. For that, we will go into the data package and create a new Kotlin class, and let's call this string sanitizer. All right, and let me just take some code here so that we don't type everything. All right, for our string sanitizer, it is a case serializer. As you see, it is a primitive. It has a primitive serial descriptor that we pass here for the primitive kind of string. And when we use that, we say that for strings during serialization, we will be using the URL encoder to encode them with our character set. And during deserialization, we will use the URL decoder to deserialize them with our character set. So now as you see, we have concentrated all this in one location. So how can we use that? We will simply go into our person class and we will mark the values that we want to use this string sanitizer. And we will do this like that, serializable with equals string sanitizer : class. Okay, and like that, we are using serialization and deserialization for the image URL. Now we're going to do the same for the landing page. And of course, now we can come here at the view model and remove this ugly code. Okay, we can go at the main screen and remove the decoder from here. And we can go to the detail screen and remove the decoder from there as well. Now, for that person, okay, I'm using this at the URLs, but I'm calling this string sanitizer instead of, let's say, URL sanitizer, because actually we use URL decoding and encoding, so we rebuild it back to the original content that it had, okay, whatever string we pass with whatever character it has. So we can mark, let's say, for example, even the name if we wanted with sanitization, if our name could have characters that wouldn't fit. Okay, so that's how it is. Let's run and see if all this works. So far it looks fine. Let me click. Perfect. So now we have the whole package. So we finished, but it was quite a lot, wasn't it? We created lots of code to pass the parcelables, and someone might wonder, is there a simpler way for this? And the answer is yes, because what we did, I have concentrated at a library I built and now I offer you for free. And by using this library, this helper library that complements this extra code, allows you to use parcelables out of the box almost as if they were primitives. So as easy almost as using primitives. So let's see how we can do that. Now, if we go into GitHub, you will see I have my library here. Let's see at the documentation how to install it. So for that, we will just need to pass this implementation, okay, to our app module, build Gradle. So let's go here and add this thing down here and okay, put it inside our catalog. So it will go to our versions catalog, let it sync. And for this actually to work first, maybe we should add the Jetpack because it's provided by Jetpack, but Jetpack is not in the default repositories. So let's go to settings Gradle and down here at the dependency resolution management, let's add this Jetpack.io and now sync. So now we will be able to get packages from Jetpack, and my package is at Jetpack, and here it is. So how we utilize this now? Now, as you will see, we don't need the string sanitizer anymore because it's included. And we don't also need here this inline function. So how we use this? We will use the mapper that comes from my NavHelper, okay? So like that. Now we use the NavHelper version of this function. So the only thing we need to do is define this type map, nothing else. Also, when it comes to the person here, now we will import the sanitizer, which will also come from the NavHelper. So now the only thing we need to do is mark with string sanitizer as serializable our strings that might cause us problems, and then just we need this one line when we create a custom type. So all you need is that person with this serializable and just this line of code, nothing else. Other than that, it's treated as if it was a primitive. So I hope you liked this, and I hope you liked also my library. If you liked this video, please thumbs up and subscribe, and also put a star to the library if you enjoy it. Thanks a lot. See ya.